All right, good morning. This is another video on our review sheet. I trust these are helping you, and I've worked hard on these for you guys. I hope you take advantage of this opportunity to learn. And so I've got some, as I have done in the other videos, I've got a couple of examples that I want to show to you as we discuss, and maybe make a diagram here or there. But really just kind of go through this with you, and I trust it's a help. We went over a couple of these in class. I want to start here with replacement level fertility. I'd like to get down to as many as I can, and by next week, I would like you to know up to the mineral deposits. All right, and then we'll go over endangered species and some of the legislations next week in our final week of review. So let's talk about some fertility. Replacement level fertility, you can see, is the number of children that a couple must have to replace themselves. All right, so in other words, if it's low in a more developed country like the United States or some countries in Europe, what have you, if this is 2.1, it would just basically allow you to replace yourself, and that would take into account mortality. In a less developed nation, an undeveloped country, third world country, the replacement level fertility is higher because it's a higher mortality rate. Remember, those countries do not have access to the same health care. The infant mortality, for example, babies are born, is just very, very, very high, and that's something to remember. So the replacement level fertility is higher in less developed countries. World population, most of you have a pretty good feel for that. I would say about 7.3, make this a little, 7.3 billion, something like that. And as we know, that figure is increasing all the time. The demographic transition model, I think we spent a lot of time in first semester on this in class. This really hooks in with the Industrial Revolution. The difference is, in other words, it measures the impact, how the demographics, how the population changed, and the percentage of populations changed as a result of the before and after the Industrial Revolution. So in the late 1870s, in the late 19th century and early 20th century. But basically, your pre-industrial stage, your birth and death rates are very high. You got to remember the overall, because of this, the overall population growth grows slowly. The infant mortality rate was very high, again, because of lack of terrible health care, didn't have many hospitals, sanitation was bad. So as a result, the overall population grows slowly. Also, birth control was really not non-existent, if you will, at that time. All right, so it's so the birth rates are pretty high at that time because of that. In the transitional stage, as better medical care came into play, the infant mortality rate drops. You still don't have as much, you still have the technology of birth control, so really the birth rates remain high, and because of this, the population grows very quickly. There is better health care, so the death rate gets lower because of better health care. The industrial stage comes in. You still have there's a decline in the birth rate, really because of birth control methods, contraception, and so forth. As people become more aware of it, start using it. Family planning comes in, and so forth. And because of this, the population growth slows. You still have lower death rates, but now that's accompanied during the industrial stage by a lower birth rate. And then the post-industrial stage, you have both low birth and death rates, so it kind of drops down with that. Age structure diagrams, if you remember, there's a number of different ones. They basically measure the rate, segments of the population, and the rate at which they are growing. So a broad base, I'm going to show you a couple of examples in just a minute. A broad base would be rapid growth. A narrow base would be negative growth, and uniform shape would be zero growth. So here's an example. I put out a couple of examples here for you. By the way, if just as a review, if you remember the way these are set up, these are basically kind of cut down the middle. There's different shapes for different countries, if you will. If I can make this a little shorter for you. All right. And this would be, the base would basically be the young age, so maybe 0 to, I don't know, 0 to 5 years. And this might be 5 to 20 years or something like that. This might be 20 to 30 years of age. All right. And if you remember, one side is men, one side is women. You'll get this. If you got a question on this, you would be given a diagram, and it would really be your job to interpret it. It could be on a free response, or it could be on a multiple choice. But anyway, this is the way it looks. So here's a couple of examples. A here, this is an example of a rapidly growing population because the base is very broad. See how wide this base is? There's a lot of babies being born, but if you look at it, they're dying off pretty quickly. So this might be a third world country. All right. This is one. B is also has a broad base, but not quite as broad. The population's growing, but slowly. All right, because the base is not quite as wide. C here, this is kind of a classic example of 0 population growth. You can see it's going to narrow in a little bit because of the people getting older, just the just natural mortality rates. D would be a classic case of a population decline. This is something that this is a growth curve, all right, or a age structure diagram, I should say, that might look something like the United States. And I've got an example here. We don't have as many babies as we had in the baby boomer generation. People like me, and born after World War II, in that generation after World War II. So you've got fewer babies. You have smaller families because of some reasons we talked about in class, right? Finances. It costs a lot of money to send a kid to college. Just costs a lot of money to live and so forth. Family planning methods are available and that type of thing. But this is where you've got a smaller base. And this is where we have such problems with Social Security. The smaller base, there's fewer people supporting a whole lot more older people. And that's probably one of our biggest issues with Social Security. And then, again, age as you go up, so the base would be the babies being born, and up here the elderly generation up top. And over here, this is an example of a country losing many young adults to diseases like AIDS. Here's where they would lose the young adults in this area here. They still have a decent birth rate. They still have notice some of the older adults are still around who have not contracted that disease like that. So anyway, that's an example of some of the age structure diagrams. I think there's a very good chance you would be asked about those. Let's go through a few of these. Most populous nations, China and India, those would be important to remember. China, with the population, has many of the same problems that we have with growing population. Densely populated cities, pollution, and so forth. Low status of women. This is directly related to education. If you're in a third world country, for example, where women do not go to college, they're not aware of what they could work for in the marketplace. They're not educated. They may not know much about birth control. And as a result, they're having a lot of babies, basically. Whereas if a woman who becomes more educated, as women started going to college in our country, the population size went down because she was working. She wasn't at home having she was working outside the home. Doesn't mean we weren't having any children, certainly, but it does mean we're having much less. So the status of women, you can see the most important factor in keeping that population rate high. And some means to decrease birth rates, family planning, contraception, economic rewards, and penalties. I think these are big in some countries like China, where if you have more than 1 or 2 children, you can check that out. I think there are tax penalties and stuff like that, or maybe an incentive not to have children, if you would. All right, composition of water on Earth. These are really mixed up, which is good. You can see the overwhelming majority of water on Earth is seawater. Only a very small amount of it, remember, 2.5%. Interestingly, that would include all the Great Lakes, all the groundwater, and so forth. So there's a vast amount of seawater. Soil salinization, I think we talked about in class, in dry regions. Basically, the minerals that are in the water are left behind in the soil with evaporation. So this can be solved by increasing irrigation. But remember, in doing so, you're going to be using more water, which is going to deplete a huge resource for us. Ask the people in California about that right now. Point source and non-point source. Point source pollution would be from a specific location, like a pipe or a smokestack. A non-point source would be, you can see, from a large area, such as agricultural runoff. This would be like fertilizer runoff. All right, which could cause eutrophication. Let's see, and traffic from cars, all kinds of traffic. The cars in many different locations, going in many different directions, kind of throwing off pollution from their exhaust pipe. BOD, we had a lab on that. This is the amount of biological oxygen demand. Sometimes this is called, it's also called biochemical oxygen demand. I think you use both of those terms interchangeably, and you can see it as the amount of dissolved oxygen needed by aerobic decomposers to break down organic materials. If you remember, we did that yeast lab. When we had that, the yeast actually broke down the glucose in our pilot study. Also on the wastewater treatment plant, this is the big job of the wastewater treatment plant, WWTP, is to get rid of this stuff. Eutrophication, green algae mats caused by an excess of nitrogen and phosphorus. You should be familiar with that. Hypoxia is basically the lack of oxygen. This is dissolved oxygen. All right, and dissolved fish need dissolved oxygen. Really, the whole aquatic life system needs dissolved oxygen for their sustenance, for aerobic respiration, and so forth. The water can't support life. So the BOD, remember, BOD and dissolved oxygen are sort of inversely proportional. Primary and secondary air pollutants. Primary air pollutants that are produced by humans. Let's see, remember this term, anthropogenic. Man-made, all right. And some of the big ones are carbon dioxide, carbon monoxide, carbon dioxide, sulfur dioxide, nitrous oxide, hydrocarbons, and particulates. I think we had an acronym there, PLONKs. Never mind, I'll get back to that in just a second. Secondary air pollutants would be caused by reaction of the primary air pollutants. A classic, we'll get to this in just a minute down below, but a classic secondary air pollutant is ozone. But so primary would be what's thrown off in the tailpipe or the smokestack or whatever, or from the cars. The secondary air pollutant